Okay, so far this unit we've talked about what rational numbers are, and we learned that they can take the form of decimals, fractions, mixed numbers, and whole numbers. And we've learned how to add and subtract positive and negative forms of rational numbers, including positive and negative integers and positive and negative decimals. Today we're going to start with how to add and subtract positive and negative fractions. So let's look at the first problem here where it says 5/7 plus 3/7. How would you go about solving that? Well, we notice that the denominators are the same, so that makes it easy. All we have to do is keep the denominator the same, and we add the numerators together. So we're going to say 5 plus 3, and that's going to be equal to 8/7. Okay, and since our denominator is the same, all we did was we added our two numerators together, and we kept that as the answer for the numerator in our final solution. Now we have to do one more step though, because this is an improper fraction. That means the numerator is larger than the denominator. What we have to do is we actually have to divide. So remember, fractions are little mini division problems, so we want to divide. We're going to say 8 divided by 7. Remember, the top number stays inside the house. So 7 goes into 8 one time, and that I'm going to take away the 7, and that leaves me with 1. So what I'm going to do is I'm going to now take that 1 remainder, I'm going to do 1, and I'm going to put it over the same denominator of 7, which is this number up front. So we have 1 part remaining out of 7 parts that we were trying to create, because we're trying to get groups of 7. So that means my final answer will be 1 and 1/7. Okay, now down here, we want to solve the following. We want to say 2/3 plus 1/4. But notice that the denominators are not the same number, so we have to be super careful here. But what we have to do is we have to make them the same denominator. So how do we do that? Well, we have to find the greatest common denominator. So in this case, we want to take a number that both of these, 3 and 4, both of those numbers are factors. So we can just take 3 times 4, and that gives me 12. So that means that 12 is divisible by 4, and 12 is divisible by 3. So if we come over here, we have to create equivalent fractions. So we're going to say 3 times 4 is going to give me 12. And we're going to say 4 times 3 is going to give me 12. But remember, what I do to the bottom, I got to do to the top. So if I multiply this by 4, then I have to multiply this by 4. And then if I'm changing this to 4 times 3, then I have to multiply the top by 3. So in this case, we're now going to recalculate the fractions and find equivalent fractions, and we're going to say 8, 2 times 4, over 12, 3 times 4, plus 3 times 1 is 3, 4 times 3 is 12. Now we have our denominators the same. If you notice, the denominators are now both 12. So now we can just add our numerators together. So we know 8 plus 3 is 11. So that's my new numerator and my final answer. And then we keep the denominator the same. Now this is just a review from last year, so you should remember this. We just found equivalent fractions. So remember, the important difference between these two steps right here is that the denominator must be the same number whenever you're adding or subtracting. Okay, now this is just adding and subtracting. Okay, and so we notice in the first problem, the denominator was the same, and that's what we call fractions with the same denominator. And then in the second problem, the denominator was not the same, and so those are different denominators. And so because of that, we will have to create equivalent fractions in order to get the same denominator. Once we have the same denominator, like we did here and here, it's easy. So what we have to do is we have to convert these to equivalent fractions if the denominator is not the same, because we have to make the denominator the same. Okay, now when we're adding and subtracting, again, the good news here is we get to use the same rules, okay? We get to use the same rules that we've learned all along with our T-chart and our SAO strategy. So remember, the T-chart has that big plus sign in it, right? So we know that we use the T-chart for adding. Oops, sorry about that. Adding. And the SO strategy, because this begins with an S, is for subtracting. Okay, now let me get rid of this real quick. Okay, so the steps for solving addition and subtraction problems with fractions is number one, step one. You want to look at the problem and you want to make sure that you convert any mixed numbers to improper fractions first. We'll do a couple of examples. So we're going to convert mixed numbers to improper fractions first. So everything's going to look like a fraction in the problem. And then we're going to check and we're going to ask, are the denominators the same or are they different? Okay, because if the denominator is the same, we get to follow these steps, and that's the easy part. This is the easiest step if the denominators are the same. If they're different, then we have to do something. We have to take a different strategy, and we want the denominators to be the same so that it does make it easy. Now today, we're just going to talk about denominators that have the same fraction. So we're going to take the easy way today. So after you determine if the denominators are the same or different, what we're going to do is we're going to have to decide whether we're going to use the T-chart or the SAO strategy. Now remember, we use the T-chart for addition because it's got that big T in the middle of it. Excuse me, the big T, which looks like a plus sign. And then we have the SAO strategy where we know that the S and the S for subtraction, that's what that means. So we know that the SAO strategy is subtraction and T-chart is addition. And then what you have to do is you're going to have to simplify your final answer. We should always reduce to the lowest possible terms. Simplify, reduce, same thing. So like I mentioned a moment ago, today we're only going to concentrate on adding and subtracting fractions with the same denominator because that is the easiest condition of our fractions for us if they're the same. So let's look at some examples. So turn to guided practice. So what we want to do, the first thing we want to start with is we want to write our T-table. Now remember, our T-table means addition. We're always going to start with our T-chart, and we have that big plus sign in the middle of the T-chart, so that means add. So if we fill out our chart, we know that whenever we have positive and negative numbers, it doesn't matter what kind of number, as long as it's a positive and a negative number, if we're adding, we use these rules. So we're going to say same sign, add, different sign, subtract, same sign, keep the sign, different, keep the larger. Okay, and let's write out the SAO strategy. Okay, S means same. We keep the first number the same. A means add. We change minus to addition. And O means opposite. We take the final number, excuse me, the last number, and we change it to its opposite. Okay, so now we have those strategies in front of us and we can refer back to them. So let's look at our steps. Okay, the first step says we need to convert any mixed numbers to improper fractions first. All right, so what that means is if you have a number like this that is a mixed number, so we have a whole number and a fraction. It doesn't know what it wants to be yet. It's a whole number and a fraction. So we have to make that look like a fraction. Well, how do we do that? Well, we can use the popcorn method, and we can say 1 and 1/8, and then we can do one of two things. We can do the popcorn method where we take the bottom number times the front number, and then we add the top number. So we're going to say 8 times 1 is 8. 8 plus 1 is 9. So we're going to say that this is equal to 9/8. Another way that you could look at this would be 1 and 1/8, and you could do what's called the check process, and you do a check mark right here, and you separate them, and you do the same thing. You say 8, the denominator, times the number in the front. So 8 times 1 is 8, plus 1 is 9, and that's going to give you 9/8. So either way you look at it, it's still going to give you 9/8. So if we rewrite our problem, we have 7/8 plus 9/8. Now we ask ourselves, are the denominators the same or are they different? And here they're the same, so that makes it really easy for us. And we look at our signs of our numbers. Are they positive or negative? These are both positive, so all I have to do is just my regular addition. And we're going to say 7 plus 9, because we just add across the top. We add my two numerators together, and we keep the denominator. And that's going to give me 7 plus 9 is 16 up top over 8. And now we have to simplify our final answer, because remember, fractions are little mini division problems. So 16 divided by 8 equals 2. Okay, so there's an example of just a normal traditional addition problem with the denominators being the same. But what happens if I have positive and negative fractions? Well, let's take a look at this next example, and this next example is subtraction. So let's look at step 1. We're going to convert any mixed numbers to improper fractions first. So we're going to rewrite this problem after we convert it. So remember, we can use the check process. Let's see if I can get my pen to write here. And we say, let me erase that real quick. And we do our check. And we say 5 times 3 is 15, plus 1 is 16. So this is negative 16. We don't want to forget the sign in front. And then we keep the same denominator of 5. So 16 over 5 minus 3/5, because that's just a traditional fraction. Okay, so now we want to check. Are the denominators the same? And in this case, they're the same, so that's good because that's the easiest. So then we want to figure out, do I use the T-chart or do I use SAO? And in this case, we notice that this is subtraction, so we're going to use our SAO SAO strategy, and I'm going to write SAO over each of the parts of the subtraction problem. And then I'm going to say the first number stays the same, negative 16 over 5. I'm going to change subtract to add, so this becomes addition. And then I'm going to change this to the opposite, so 3/5. The opposite of positive 3/5 is negative 3/5. Okay. Now we have addition and we have two negative numbers. So do we want to use the SAO or the T-chart? Well, we figured out we needed to use the SAO, and now we have addition. So now we can do what? We can use the T-chart to solve. So we know that the signs are different. So, excuse me, the signs are the same. So according to the T-chart, we add the numbers together and we keep the negative sign. Now we're only looking at the numerators at this point. So we're saying negative 16 plus negative 3. So the rule says we add the numbers together. 16 plus 3 is 19. And then we keep the sign. And the sign of both of those numbers is negative, so we want that to be negative 19. So my answer becomes negative 19 over, and then I keep the same denominator, over 5. But here I have to simplify. I cannot have an answer where I have an improper fraction where the numerator is larger than the denominator. So what we want to do is we want to go ahead and we want to divide that out. My answer has to be negative. So we're going to say 19 divided by 5. So 5 goes into 19. Let's see, 4 times 5 will be 20. That's too big. So we'll say 5 times 3 is 15. And 19 minus 15 is 4. So remember, I'm going to take the remaining part that's left, 4, I'm going to put it over the divisor. So we're going to say 4 over 5. So we just take our remainder, 4, and we put it over top of the number that's in the front of the division sign. So it's 4 over 5. And it has to be negative because my final answer was negative here. So the answer would be negative 3 4/5. And that would be our final answer. Okay, so now you get to practice. And remember, you want to write down your T-chart first whenever you do these problems and your SAO strategy. So we have our T-chart, that means addition. We're going to say same, different. Same sign, we're going to add the two numbers together. Different signs, we're going to subtract. And then same, we keep the sign. And then if they're different, we keep the larger. And then SAO stands for what? Same, add, and then opposite. And those are the steps for subtracting. Okay, now you can work on your classwork.